Welcome everybody. In this session, we will be studying about the merits and demerits of Mendeleev's periodic table. As you know, Mendeleev's periodic table was a very successful attempt in classifying the known elements at that time. His periodic table had a lot of merits, and owing to these merits, it was accepted at that time. But then, slowly, some scientists unraveled various demerits too. So, we will be focusing first on the merits. The first merit which is mentioned is about atomic masses. The atomic masses of some elements were revised so that they could be given a proper place in accordance with their properties. Earlier, atomic mass of beryllium was considered to be 14.09, and that was found to be untrue, and the atomic mass of beryllium was corrected from 14.9 to 9.4, and in the periodic table beryllium was placed before boron. So, what does the first point say? That atomic masses of some elements were revised so as to give them a proper place in the periodic table in accordance with their properties. It tells us that the atomic masses of some elements were revised so as to give them a proper place in the periodic table in accordance with their properties. For example, the previously determined atomic mass of beryllium, that was 14.9, was changed to the correct value of 9.4, and that beryllium was placed before boron. Coming to the second point, if you look into Mendeleev's periodic table, there are many vacant spaces. So, Mendeleev had kept vacant spaces in his periodic table for elements which were not discovered, and he had named them eka boron, eka aluminium, and eka silicon. So, Mendeleev had kept vacant spaces in the periodic table for elements which were not discovered then, and three of these unknown elements were given the name eka boron, eka aluminium, and eka silicon. Their atomic masses were indicated as 46, 44, 68 and 72 respectively. Their atomic masses were indicated as 44, 68 and 72 respectively. And he had not only given them names, but he had predicted their properties also. And the interesting point is that later, when these elements were discovered, they were named as scandium, gallium, and germanium, and the properties matched well. The properties matched well with those he had predicted. So, what does the second point say? Second point tells us that Mendeleev had kept vacant spaces for elements which were not discovered then. Three of these unknown elements were named as eka boron, eka aluminium, and eka silicon, and their atomic masses were indicated as 44, 68 and 72. He had predicted their properties also. Later, the elements were discovered. They were scandium, gallium, and germanium, and the properties matched well with those he had predicted. So, let us try to think about the second point. Mendeleev kept vacant spaces in the periodic table for elements which were not discovered till that time. Three of these unknown elements were named as eka boron, eka aluminium, eka silicon, and their atomic masses were indicated as 44, 68 and 72 respectively. He had predicted their properties also, and later the elements were discovered and named as scandium, gallium and germanium, and the properties matched well with those he had predicted. And when this was proved, then Mendeleev's periodic table was given more prominence and his methods of classification were accepted. So he had predicted, if you look in the periodic table, he had predicted the properties, and aluminium as atomic mass 68, and when it was discovered it was 69.7. You can see how close they are, 5.9 density, 5.94, right? Formula of the oxide E2O3, here it is Ga2O3, amphoteric, so it is almost exact. Now coming to the third point, there was no reserved place for noble gases, that we know, because noble gases were not discovered, and noble gases like helium, neon, argon were discovered only towards the end of the century. Yet when they were discovered, Mendeleev created the zero group without disturbing the original periodic table. That was the most interesting part, right? He placed zero group elements without disturbing the periodic table, original periodic table, and these noble elements fitted well. So how do we write this point in the exam? It will be written as, there was no place reserved for noble gases in the periodic table. There was no place reserved for noble gases in Mendeleev's original periodic table. However, when noble gases like helium, neon and argon were discovered towards the end of the 19th century, Mendeleev created a zero group without disturbing the existing elements, and the noble gases fitted very well. So these are the three important merits of Mendeleev's periodic table. Moving to the demerits, which are really demerits due to which the scientists had to create a better periodic table. We will see later who was the scientist who was responsible for giving the modern periodic law. So focusing on the demerit, the first point tells us that the whole number atomic masses of cobalt and nickel is the same. Therefore, there is an ambiguity regarding the sequence in the periodic table. Now, what does this mean? The meaning is, if you look at the atomic masses of cobalt and nickel, they are the same. So, in that sense, then if the periodic table is based on atomic masses, there was ambiguity in the sequence, that is, where would these elements be placed, which would be placed first and which would be placed later. So that was the problem. So the point tells us that the whole number atomic mass of cobalt and nickel is the same, and therefore there was ambiguity regarding the sequence in the periodic table. Second point tells us that the isotopes which were discovered long time after Mendeleev put forth this periodic table, and placing these isotopes was a very big problem, because isotopes are elements which have the same chemical properties. You have studied isotopes, that they have the same atomic number but different atomic mass number. So placing them was a challenge in the periodic table, and because, for example, if you take chlorine, you have two isotopes, 35 and 37, and chlorine has the same chemical properties. So where would you place chlorine? Will you place 35 before 37, or chlorine, both of the chlorine should be placed together? It is really difficult to think. That was a problem in Mendeleev's periodic table. And the third point is also a major point, that is, when the elements are arranged in their increasing order of atomic masses, the rise in the atomic masses does not appear to be uniform. So there is no strict uniformity, like if you say there is an increase of 1, 2, 3, 4, 5, and the next one you can say 6th. So suppose there is an increase like 1, 2, 3, 4, 5, and then there is a vacant space and then 7, then you can say yes, there can be one element in 6th. But when it is not uniform, like if it is 1, 3, 5, 7, still you can say. But if it is 1, 3, 7, 8. So there is no uniformity. In absence of that uniformity, we could not predict how many elements could be present between two elements. And the last one is a very major one. If we look at the position of hydrogen, Mendeleev's periodic table does not justify the position of hydrogen. That is, hydrogen has a lot of similarities with halogens. For example, if you see the molecular formula of hydrogen, it is H2, which is similar to the halogens like fluorine, which is F2, and chlorine, which is Cl2. Similarly, hydrogen has a similarity in the chemical properties, okay, with alkali metals. For example, if you take alkali metals of sodium and potassium and you make the compound of sodium, okay, so you will have here sodium chloride. If you take sodium with oxygen, sodium oxide, sodium sulfide. Similarly, hydrogen had, you can see similar type of molecular formulae like hydrogen chloride, water, and hydrogen sulfide. So if you look into hydrogen, it has a unique property, like it has similarity with the halogens as well as it has similarity with the alkali metals. So placing hydrogen was a big issue, and it was really difficult to place hydrogen, and it could not be decided. So you have this point, it cannot be decided whether the correct position of hydrogen is in the group of alkali metals or in the group of halogens. So how do you write this point for the exam is like exactly how it is mentioned here. Hydrogen shows similarity with halogens. For example, molecular formula of hydrogen is H2, while molecular formula of fluorine and chlorine is F2 and Cl2. Similarly, there is a similarity in the chemical properties of hydrogen and alkali metals. If we look at the molecular formula of alkali metals with compounds like with elements like chlorine, oxygen, then we can say sodium forms sodium chloride, it forms sodium oxide. Similarly, hydrogen also forms hydrogen chloride, water, hydrogen sulfide. That is why it could not be decided what is the correct position of hydrogen, whether it should be placed with halogens in the group 6 or it should be placed along with alkali metals. So these were the merits and demerits which are asked separately in the exam, can be asked together as explain the merits and demerits for 4 marks, then you have to write 2 merits and 2 demerits. If it will be asked for 2 marks, then it will be only merits or demerits. So you can listen to this video many times and keep on revising the points till you are perfect. Thank you.